Hi future scientists, this is Ma'am M and I will be your Science Saya mentor in Science 8 for today. Grade 8, Force, Motion, and Energy. Last time we discussed about Part 1, Potential Energy. This time we will proceed to Science 8, Unit 1, Module 3, Part 2, Kinetic Energy. Objectives. Number 1, define kinetic energy. Number 2, determine the factors that affect the kinetic energy of an object. Number 3, calculate the kinetic energy of an object. Let's start with essential question number 1. What is kinetic energy? In physics, kinetic energy is the energy possessed by an object when it starts to move. The word kinetic comes from the Greek word kinetikos, which means moving. Essential question number 2. What are the factors that affect the kinetic energy of an object? The two main factors are mass and speed. This means that the heavier and faster an object moves, the greater its kinetic energy. Essential question number 3. How to calculate the kinetic energy of an object? Let us have this mathematical equation. Kinetic energy is equal to 1/2 times mass times velocity squared, or Ke is equal to 1/2 mv squared, where Ke is expressed as kilogram meter squared per second squared or Newton meter or joules. M refers to mass expressed in kilogram or kg, and V refers to speed expressed in meter per second. Do not be confused. The velocity here is also the same with the speed. The difference is that the speed has magnitude only, while velocity has magnitude and direction. That's why it is called as a vector quantity, and the speed is an example of a scalar quantity. Essential question number 4. What will happen to the kinetic energy of an object if its mass is doubled but the velocity remains the same? Because kinetic energy is directly proportional to the mass, the kinetic energy also doubled. Essential question number 5. How about what will happen to the kinetic energy of an object if its velocity is doubled but the mass remains the same? Using this illustration shows that when we double the velocity, the kinetic energy increases by a factor of 4. Using the Gressa method, let's try to answer this sample problem. What is the kinetic energy of a 1,550 kilogram automobile traveling at 25 meter per second? Take note that kinetic energy is equal to 1/2 times mass times velocity squared. Applying the Gressa method, let's identify G, which is the given. So here we have mass is equal to 1,550 kilogram, which is the mass of the automobile. V is the velocity or speed, which is 25 meter per second. And using the Gressa method, we have R, which is required or unknown, which is here we are looking for kinetic energy. E in the Gressa method stands for equation or formula, so Ke is equal to 1/2 mv squared. S or solution, so let's plug in the values. Then A stands for answer, wherein kinetic energy is equal to 484 joules. Let's try this. Which of the two vehicles has the higher amount of kinetic energy? A car with a speed of 4 meter per second, or B, bus with a speed of 4 meter per second. Kinetic energy is directly proportional to mass. The greater the mass, the greater the kinetic energy. So if you answered letter B, bus with a speed of 4 meter per second, you're correct. Did you get it right? If yes, very good. If no, don't worry, you may rewatch this video and try again. Remember, the factors that affect the rate of kinetic energy are the object's mass and velocity. The greater the mass of the moving object, the greater the kinetic energy. The greater the velocity of a moving object, the greater is the kinetic energy. The law of conservation of energy states that the lost potential energy would be gained as kinetic energy. Energy is transferred from one form to another. And in the case of the transfer of energy from potential energy to kinetic energy, the total mechanical energy is conserved. Did you learn something today? I would love to know. If yes, don't forget to type in the comment section #kinetic energy. Are you ready for the part 3? Part 3 sounds. For more videos, don't forget to like, comment, and subscribe.